Hello and welcome to everyone. This is Neeraj Gautam. In our last class, we discussed about the governors and solved some problems based on the governors. From today's class, we are going to start the flywheels. Before starting flywheel, I will introduce you with the inertia forces acting in the reciprocating parts of an engine. Because by analysis of the inertial forces, we can perform the analysis of turning moment, and by using turning moment diagram, we will use the fluctuations in the turning moment of an engine during a cycle. To suppress those fluctuation, we will use the flywheels. So let's start today's class with the definition of inertia forces. Inertia forces comes into the picture after the alembert principle. So first, we will define the alembert principle. Now, the D'Alembert principle states that the resultant force acting on a body together with the reversed effective force or the inertia force are in equilibrium. To understand this, let us consider a body of mass m and let a force F is applied on it, because of which this body is moving along the line of action of this force. This direction is the direction of motion of body, and the force is created, the acceleration A. Then by Second's law of motion and Newton's second law of motion, Newton's second law of motion, F is equals to mass into acceleration. Now according to the D'Alembert's principle, if I apply a reverse effective force, the resultant force acting on a body, that means the net summation of the forces acting on the body, together with the reverse effective force, that means the force which is responsible for the motion. Here the force responsible for motion is F, which is equal to the ma. Okay, so if the mass into acceleration is the force responsible for this motion, if I apply this force on the body in reverse direction, m into a, then together with these both forces F as well as ma, the body will be in the state of equilibrium. So F minus ma, the net resultant force acting on the body, together with the resultant reversed effective force ma, is equals to 0. Since the summation of all forces implies that the summation of forces plus reversed effective force, that means responsible for motion, is equals to 0. You can see here the reversed effective force is equal to the minus of ma, and this is the externally applied. Externally applied on body. Okay, so this minus of ma is the reverse effective force. It is basically the resisting force, the force which is trying to resist the motion of body, and the resistance to the motion is called as inertia. So This force is called as inertia force. So now we can here define inertia forces. Inertia forces are inertia forces are the imaginary force applied on the body to bring the body is in equilibrium. That means an imaginary force, whenever it applied on the body, then it brings the body in a state of equilibrium. That means it brings the body is in static condition. So using this principle, we can analyze any dynamic body by bringing it into the static equilibrium conditions easily using equations of static equilibrium. Okay. So this is the D'Alembert principle. Now we can see here in inertia forces there is a component of acceleration. So in which direction you want to analyze the inertia force acting on any body, you must know the acceleration of body in that direction. Now, in the analysis of IC engine, if I want to determine the value of inertia forces acting on various components of engine, then I must know about the acceleration of those components for which I want to study the inertia force. We also know that the IC engine mechanism is simple slider crank mechanism. So let's start the analysis of slider crank mechanism or IC engine basic mechanism for velocity and acceleration by analytical method. Okay, so we'll see the analytical method to determine the velocity and acceleration first. After determining the acceleration, we will find the forces, inertia forces acting on piston, connecting rod, crank pin, and all. Okay. If you have any doubt or query related to this session, you can contact us. Thank you.